All right, guys, welcome to building an X-ray tube. So we're going to be drawing on this screen that you guys see here that's in front of you. If you want to sketch along with me, you are more than welcome to. What I've put on here for very first one is the things we already know from the last video. So we're building an X-ray tube. The X-ray tube is where X-rays are going to be formed. You guys read that there was a positively charged anode and a negatively charged cathode. And then I've also drawn in here for you where our anode is. So this here will be our anode. You can see I've labeled it as being positive. We talked about it being made of copper. I've drawn for you guys the target here, and that's made of tungsten. On the cathode side over here, I drew in for you guys the cathode, labeled as being negatively charged. I have our coil in here, and the focusing cup, coil being made of tungsten, focusing cup being made of molybdenum. That's a lot of metals. I'm going to tell you guys a few more as we go along as well. Why is it important? Because you guys are going to see it on your VT&E. They're going to ask you what type of metals that these different parts of the X-ray tube are made out of. So start learning them now. The more you put them into your mind now, the easier that will be when it comes to your test taking time. Okay, so what I have sketched for you guys on here is our next stage of the X-ray tube. So here we are applying heat. We are going to be doing something that applies heat to that filament. The filament's going to get hot. The electrons are going to get really excited. They're going to break free of their orbit. They are negatively charged. They are going to want to fly this direction because there's something positive over there, our anode. And then they're going to fly over and they're going to strike the target of the anode. When they strike the target of the anode, they are going to change directions. When they change directions, they are going to fly down, and now their name is going to change to photons. The photon is our X-ray. Remember this? It's the bundle of energy. Electromagnetic radiation. These guys have short wavelengths and high frequencies so that they have enough energy to penetrate through our objects and create an X-ray image on our film. Now the one important thing I want you guys to see on here is this target right here. The target of the anode is the site of X-ray generation. That's really important that you know. Until the electrons hit that target, they are just electrons. Here we have excited electrons flying over it. They hit the target. They turn into X-rays and they come down. And they are going to be exiting our machine through a window right here. One more thing I'm going to add for you guys here. This window is made of beryllium. That is the only place that X-rays can leave the machine. All right, and here's our next slide. I've added some more information for you guys onto this one we're going to go over. So first thing I want to talk about is we talked right here at that target, the site of X-ray generation, and that we're using a lot of heat. Remember, a lot of heat. We're using tungsten because it can really resist pitting. So when these electrons hit, we can control the direction that they're flying in. If this gets pitted, then the electrons are going to kind of start doing different things and we're going to get more scatter radiation. This is hot. At this target, 99% of the energy turns into heat. Only 1% of these coming around turn into X-rays. So this is an incredibly hot activity that's occurring. That's why this was made out of copper, because it's really good at dissipating heat. And we want to get the heat away from our anode as quickly as possible. We'll put a little plug in here. We're going to talk about this in module or later in the module. Remember, this is hot. The more we can do to get the anode cool, the better. We're going to talk about different types of anodes and why some of them are better at getting heat away from this than others are. The next things I put on here was a few other aspects about how this X-ray tube is built. First of all, inside of it, I want you guys to know that this is a vacuum. Then there's no air anywhere inside this X-ray tube, which is designed to allow us to control the electron flow. If there was nothing impeding these electrons, they're going to go straight from here, they're going to hit the target and come directly out that window. If there was other things inside here for these electrons to hit, they would start creating photons at that point. We want to control what they hit, and we only want them to hit the target of the anode, which means we put this into a vacuum. Now, how is the outside of this machine made? Number one, the very outside layer here, this is a metal housing. It's there to protect your X-ray tube, and it's also there to prevent escape radiation. So it's important for you guys as you're managing your machines and looking at them that you make sure this metal housing is always intact. If something occurs to your metal housing and it gets cracked or dented, you could be sitting in a scenario where radiation is being allowed to escape out of your X-ray tube. And that's not a scenario we want for anybody's health or safety. The inside layer of your X-ray tube is made out of a glass envelope. And between these two layers, there's a layer of oil. It's simply there to cool. 99% heat, we need to cool this thing off so we don't get burned when we're touching our X-ray machine. That's what this oil layer is doing, is helping cool off the X-ray tube. Next thing I added to the slide is how these X-rays are getting out, right? So we have a metal housing, no X-rays get out. We're going to control where the X-rays leave. They're going to leave out of that window that was made out of beryllium. And we also have collimation plates in here that are made out of lead that we can slide back and forth so we can control the size of this window. We're going to talk a lot more about collimation in modules 5 and coming up in modules 5 and in our labs. But essentially we want this window to be as small as possible while still getting all the parts of the radiographic image that we're trying to obtain. So we'll be using collimation plates to do that. These are made out of lead, so radiation cannot get through them. Alright guys, one quick thing added on here for you guys I want you to pay attention to is we're going to expand on this filament a little bit. So remember, when we're taking our X-rays, we have a choice of 2 different MAs. We can either choose 100 or 300 MA. 100 MA is going to be associated with a smaller filament and a smaller focusing cup. 300 MA is going to have a larger filament and a larger focusing cup. Our benefit of 300 MA is this larger filament. We can make it hotter, which means we can get more electrons to break free, and we can have more electrons creating more photon beams for us. So this is going to be great for our bigger, thicker objects where we just need more X-rays, more photons to go around to create that image. Now for our smaller ones, we can get away with a 100 MA. We can get away with fewer photons. And this is going to have a smaller filament, a smaller focusing cup. Further on in this module, you're going to learn a little bit more, but the smaller your focusing cup is, the crisper and clearer that your image is going to look. So if you can get away with 100 MA, it's great to do it. But big, thick objects, you might not get enough numbers, so you may have to do 300. Okay, now take a deep breath. We're switching gears and dropping to the bottom of this diagram. But now we've talked all about what happens in here. You guys know how we're getting X-rays, how they're getting out, what all these things are made out of, but how does that actually happen? How do you set that? So this is all going to come back. We're going to start with an outlet. Our X-ray machine is plugged into an outlet. We have 2 different types of energy that come out of an outlet, amps and voltage. On this slide, I'm just going to focus on the amps part of our electrical circuit in the United States. So coming out of our outlet, we have amps. Amps are running to a switch on the machine. On the machine, you have an MA selector dial. When you select this dial, you are selecting either 100 or 300. So whatever you select on this dial is going to be the coil that the machine heats up. Either the 100 MA coil or the 300 MA coil. We still have amps that are coming out of here, but notice this is amps coming out of our circuit. We're only caring about milliamps. Everything's in milliamps. Amperage is just way too much. If we applied amps to one of our coils, we'd just burn it out. It doesn't have the capacity to handle such levels of heat. So we need to somehow take our amps and turn them into milliamps. And that's what's happening here at this step-down transformer. Its job is to take the amps coming in from our circuit and step them down and turn them into milliamps so that we can use them to heat up our coils. So after the step-down transformer, we have sorry guys, that was really big. We have MA. So now we have our milliamps coming in and heating up the filament of our cathode in order to get those electrons to break free and this whole process to start. Now we're looking at the other side of our machine. Here we're back to our outlet, and now we have volts coming out on the other side. Volts are going to come up. They are going to go through a kVp selector. So you're going to be on your kVp dial and you're going to be saying, what do I want the kVp to be? 40, 50, 120? Whatever you select here is how positive you're going to make this anode. So if you select 80, this is going to be pretty positive. Those electrons are going to move pretty fast, have a lot of force, you're going to get good penetration power. If you have something smaller and you select like 42 as a kVp, this is going to be less positive, so these electrons are going to leave slower, and your X-rays are going to have less force and less penetration power. Great for our thinner objects. kVp selector also goes by another name called the auto transformer. Sorry guys, you just need to know the two different names for it. So here we have volts that were leaving the machine. We had a kVp selector and we have volts again. But notice everything we're talking about here is kilovolts. Those are bigger than volts. Volts isn't enough to make this positive enough. So we have to step up our volts. So here we're going from volts into a step up transformer. From the step up transformer, now they are going to be turned in to kilovolts. We're going to have kilovolts, and then we are going to be able to create or choose our kVp. So here we have our kVp determining just how positive that anode is going to be, how much force your electrons are going to have, and what kind of penetration power you're going to get. So here I'm just going to leave this up for a few seconds, but if you want to screenshot it, I'm pretty sure this covers all the different drawings and sketchings that I've done up until this point in one complete diagram for you guys. So this is just one last thing we need to add in to understanding how our X-ray machine works. And this is thinking back to that outlet and our electrical cycle in the United States. Our electricity comes in a 60 cycle per second fashion. When our electricity is coming in, it's coming in a wave. Half the time the wave is on a positive aspect, half of it is in the negative portion. When we're dealing with X-rays, we want it to be positive, right? We are trying to use that electricity to create positivity at the anode. So this is great, but it's only positive half the time. The other half the time it's negative. So we have a couple things that the electricity goes through in order to improve this for us. The first thing it's going to go through is something called a rectifier. The job of a rectifier is going to be to get rid of all the negatives. So it blocks the negative cycle. So now we're better. It's always positive, but it's only positive half the time. So the next thing it goes through is a generator. The generator's job is to double this. So now it's positive all the time, and we're getting 120 positive spikes every second due to the generator. And that's as much detail as you guys need to know that portion in. So that's where I'm going to leave it for you guys. If you want to test yourselves, I'll leave this one up here for you guys for a few seconds. Here's the very blank item that we started with. So feel free to screenshot this, make copies of it, do whatever you need to as you practice.